Okay, ladies and gentlemen, you are welcome. So in today's video, we are going to look at we are going to do organic chemistry, specifically IFAC nomenclature of alkanes. So the IFAC means the I stand for International Union of Pure and Applied Chemistry. So the IFAC means International Union of Pure and Applied Chemistry, while the word nomenclature means naming. So it means that in a simple term, when we said IFAC nomenclature, it means the naming of organic or the naming of alkanes. And don't forget, ladies and gentlemen, when we started this class or when we started with the organic chemistry, I told you that alkanes, it is the first member of organic chemistry and it has a general formula of CN H2N plus 2. So this is the general formula for alkanes. And examples of these alkanes is like, for example, when we have N is equal to 1, so we have C1 H2 times 1 plus 2, and this will give us CH2. C times 1 is C, 2 times 1 is 2 plus 2, making 4. So this is what we call methane. This is methane. And we have so many other members of this alkane. We have ethane, we have propane, and we have butane. So without wasting much of our time, we are going to look at the set of rules that we use in naming organic compound. So the first thing, let's say we have a compound like this. So we have a compound like this, ladies and gentlemen. So, so we have a compound like this. So we want to name a compound like this. So what are the rules do we have, or what are the set of rules do we have to apply in naming organic compound? So the first thing, ladies and gentlemen, is to identify, identi, identify the parent compound. Identify the parent compound or the parent chain. So after you do that, then you name it. So how do we know the parent chain? We have to count the number of carbon. So the one that gives us the longest carbon chain, the longest continuous carbon chain is the parent chain. Like for example, let's look at it. Let's count from here. 1, 2, 3, 4, 5, 6. So if we count straight like this, we have 6 carbon. And if we count from here, 1, 2, 3, 4, 5. So from this to this, we have 5. So you see, by counting here is 5, and by counting here is 6. So you can also count from here, 1, 2, 3, 4, 5. So here is also 5. So if you can see, ladies and gentlemen, from here, the longest chain in this compound is 6. Is 6. So therefore, the parent chain or the parent compound or the parent chain here is hexane, because it is the longest carbon continuous chain. So, ladies and gentlemen, what I want to say here is that whenever you are given organic compound, to name, the first thing to do is to count the longest carbon continuous chain, and this apply to any family of organic compounds, whether it is alkane, alkene, alkanoic. Always do that. You count the longest carbon continuous chain. Although, in the case of non-hydrocarbons, those that have functional group, sometimes you always count from the functional group. So, but at this point, the longest carbon continuous change is hexane, not pentane, because the pentane is the lowest one. Is the lowest one. So after you do that, then identify the position of the substituents. Identify the position of the substituents. What are the substituents? So here it is a substituent. Here is also a substituent. So we have two substituents. So, but how do we number them and how do we name them? So the first thing to do is that if you count from here, we know that it is 6. So let's count from here: 1, 2, 3, 4, 5, 6. So if you look at it from here at 1, 2, 3, at position 3, we have substituents. And the substituent is methyl. So at position 3, we have methyl. And if you also continuous at carbon 4, carbon 3 and 4, we have methyl. So the best thing to do, because all they are methyl, so we can now say at position 3 and 4, position 3 and 4, we have methyl. So therefore, we are now going to say 3,4 dimethyl. So it means that at position 3, we have methyl, and at position 4, we have methyl. So that is why here we have 3,4 hyphen, because it is 2, so that is why it is dimethyl. So I have 3,4 dimethyl. So the longest carbon chain here, is hexane. So we can leave it as 3,4 dimethyl hexane. But while naming, ladies and gentlemen, it is very important to know that we usually take the one that will give us the lowest possible number. So the next thing after identifying the position of the substituent is also to get the lowest possible number. Because this number here, if we add them, we have 3 plus 4, and this will give us 7. So we have 7. So what if we count from this direction, ladies and gentlemen? Let's say we have 1 here, we have 2, we have 3, we have 4, we have 5, and we have 6. So if you also count from here 1, 2, 3, you can see that at position 3, we have methyl, and also at position 4, we have methyl. So we have 3,4 dimethyl hexane. So you see, if we now take this 3 plus 4, it will still give us 7. So it means that any numbering you take, it will give you the same thing. So therefore, this is correct and this one is also correct, ladies and gentlemen. I hope you understand. So the best thing to name organic compound is to count the number of the substituent. And if you have more than one substituent, assuming now you have more than one substituent, so you have to follow them in alphabetical order. Like for example, here is methyl. What if you have ethyl? Let me give you an example. When I write something like this, ladies and gentlemen, it means the same thing. So now if I ask you what is the name of this compound, who can tell me? I gave you 1 second, so I gave you 1 minute, write the name of this compound. 1 minute, write the name of this compound. 1 minute to write the name of the compound. Okay, so it means that here you have 1, you have 2, 3, 4, 5, 6, 7, 8. It means that you have 8 carbon. You have a total of 8 carbon. So therefore, this is to tell you, since there is no any double bond, because if there is double bond, it will be indicated. If there is any substituent, it will also be indicated. So therefore, this is a typical octane. This is octane. It is octane. So let's assume here we have something like this. And let's see here we have something like this. And here, let's say we have, let's say still here, we have Cl. So you see, ladies and gentlemen, you can see clearly we have about 4 substituents. This is a substituent, this is a substituent, and this is a substituent, and this is also a substituent. So how many substituents do we have here? We have 4 substituents. We have bromine, we have chlorine. This is what? Who can tell me what is this? We have 1, 2 here. So it is ethyl. And this one is methyl. So it means that you now have a substituent at different position. We have a substituent at different position. So what do we do? So this is bromine, this is chlorine, this is ethyl, this is methyl. So the best thing to do here, because bromine comes first, followed by chlorine, then ethyl, then methyl. So at position 5, by this numbering 1, 2, 3, 4, 5. At position 5, we have bromine. So therefore, we now have 5 bromo. So bromine, or any member of halogens, it usually change to, or it end with O. Chlorine change to chloro, bromine change to bromo, iodine change to iodo. So therefore, this is bromo. So 5 bromo. Position 4, we have chlorine. So we have 3 chloro. Then at position 4, still the same. Okay. No, here, okay. The chlorine is at position 4, so it's not at position 3. So we have 4 bromo. And still at carbon 4, we have ethyl. So we have 4 ethyl, 4 ethyl, and then we have methyl carbon 6. So we have 6 methyl. And then the parent name is octane. So you add octane. So what do you do now? Is this correct? We are not sure. So therefore, we can also, you see, we counted from this direction, from right to the left. So we are now count from left to the right, and we'll see what we are going to have. So if you count from here, let me use blue. So I have 1 here, I have 2 here, I have 3 here, I have 4 here, I have 5 here, I have 6 here, I have 7 here, and I have 8. So if we follow it in this direction, at what position do we have bromine? Because we have to start from alphabetical order. So at carbon 4, we have bromine. So let me write it here. So we have 4 bromo. So we have 4 bromo. Then the next one is chloro. So we have 5 chloro. So the chlorine is at carbon 5. So we have 5 chloro. And then we have the ethyl is also at 5. So we have 5 ethyl. Then after ethyl, then the next thing is methyl. So the methyl is carbon 3. So we have 3 methyl. And then the parent name is octane. So how do we know which one is correct? So we have to count the numbers. So how do you count the numbers? Here we have 4 plus 5 plus 5 plus 3. So this plus this, we have 9, we have 13, we have 17. So everything here is 17. So we have 17 here. Then what about this one? Let's also count this. So 5 plus 4 plus 4. So this 10, because we have 6. This 6 plus 4 plus 4 plus 5. This will give us 19. So which one carried the highest number between this one and this one? So this one carry the highest number. So this one is wrong. This one that has the lowest number is correct. So therefore, we have 4 bromo, 5 chloro, 5 ethyl, 3 methyl octane. So this is correct. So ladies and gentlemen, the first thing you do in organic chemistry, if you are given an organic compound, get the longest carbon chain. Then after you get the longest carbon chain, then the next thing after you do that, then you now try to identify the position of the substituent. So if you identify the position of the substituent, then the next thing is to number them. You number the substituent. So after you number the substituent, then you write the name. Between number to number, you use comma. So that is why here, if you look at it, between number and number, we use a comma. And between a number and alphabet, you use hyphen. So that is how you do it. So this is actually a basic rules in naming alkenes. You identify the longest parent chain. After you do that, then the next thing you identify the substituent and their position and their respective position. Then you name them in alphabetical order. So ladies and gentlemen, let me give you some questions to try. So now you have these 2 questions. Try them. Name these 2 compounds and give the answer on the comment section of this video. Name this compound and write their name on the comment section of this video. And ladies and gentlemen, I also want to tell you something very important. Apart from giving organic compound to name them, you can also be given the name of the compound to write their structure. So you can be given a compound like, for example, 2, 2, 3, methyl, and 10. So you may be given a compound like this. So you will be given the name of the compound and you may be asked to write the name of the, to write the structure of the compound. So you can see clearly here, we are given 2,2,3 methyl pentane. And you are to write the name, you are to draw the structure. So you see from here, the first thing to do is that the parent name is octane. So you draw pentane. The parent name is pentane. So you draw 5 carbon. At position 2, you have methyl. At position 3, you have methyl. So it means that there is a methyl here, and also there is also methyl here. So at position 2, we have methyl. Then also at position 3, we have methyl. So we have to draw it here. So we have methyl at this position. So this is, you have the name and you draw the structure. So you'll be given a name and you will draw the structure of the compound. So you have to complete this. And this is all hydrogen atoms. This one is also hydrogen atoms and this one is hydrogen atoms. So it means that from here, you are given the name of the compound and you also draw the structure of the compound. So you can have so many examples like this. So let me give also another examples where we have, let's say we have 2 bromo, 3 chloro, 5 iodo, then 6 methyl octane. So you see, in this case, we have about 4 substituents. We have bromo, we have chloro, we have iodo, and we have methyl. So the first thing to do is to write or to draw the parent name, which is octane. And from octane, you locate the position of each of the substituent. So we are now going to draw octane, which is 8 carbon. One, two, three, four, five, six, 7, 8. So this is 8. So you see at position 2, we have bromo. So it means that we come here, this is 1, 2. So you can even write or you can number the carbon in the compound. So we have 1, we have 2, we have 3, 4, 5, 6, 7, 8. So at position 2, we have bromo. So we draw bromo here. Then at position 5, we have iodo. So we write iodo. At position 3, we have chloro. So we write chloro here. Then at position 6, we have methyl. So we now have methyl here. So you see, all the 4 substituents are now placed in the compound. So we have methyl. So we have 1, 2, 3, 4 substituents. We have them here 1, 2, 3, 4. So then the next thing is to complete the carbon atom. So all this is hydrogen. Here is also hydrogen. Here is also hydrogen. Of course, here is also hydrogen. Hydrogen here, hydrogen. Here is also hydrogen. Here is also hydrogen. And we have 3 hydrogen here. So this is how to draw the structure of the compound from the name. So you can be given a compound to draw the name of the compound. So to name the compound, and you may also be given the name of the compound to draw the structure. So this is what you call, or this is how the IFAC nomenclature of alkanes are. So I will now give you 2 more names to draw the structure of the compound, and I want the answer, or I need the answer, snap it and place it on the comment section of the video. So now we have 1, 2, 2, 2, dichloro. So we have 2, 2, dichloro, 3, methyl hexane. So this is the first one. And then the second one, we have, that is number 2, we have 2, 2, diethyl, 3, methyl nonene. So please, ladies and gentlemen, this is the name of the compound. These are the names of the compounds, so please draw the structure. And this is also the structure of the compound, give them names. So ladies and gentlemen, please don't forget to subscribe and join to my YouTube community for more videos. Thank you very much and see you next. Bye bye.